Yeah, so thank you for coming. My name is Devon Stewart. I am available via those things. I'm going to be taking a little bit of a different tack from the rest of the conference. So I know that you've all been kind of indoctrinated on all of this functional mumbo jumbo. This has been a lot of fun. So let's take a step back to reality now. Kind of pull back. This is the last day, so let's evaluate some alternate strategies from some of the stuff that we've seen today. So, first thing is, what are we going to actually look at? This is also going to be written in, or this is going to be given in Scala. So, if you're not familiar with Scala, most of the code is actually defined in the slides. There's one thing, there's option, which is a Scala built-in. It's a kind of provided by the standard library. Beyond that, all the code is actually going to be in each slide. So if there are any questions, feel free to shout them out. Although I do have limited time, so might have to cut them short and save them to the end. So if it does go long, that's just where we'll have to be. So first thing is, let's look at option, right? So this is what are we to start. What does this actually do? So this is some normal Scala code. So you've got option wrapping a Java function. So that Java function could return null, could return a valid value. But now, when we actually use it, what are we doing? What is a map? What is it actually? Do I actually have to read all this stuff? Do I have to keep all the types in my head? So if I run this, we can see. Oh, sure enough, we had a null value, but now instead of a normal null value, now I have this option. So what do I do with an option, right? That doesn't help me with anything. So I have to actually maintain the structure of all of these functions. I have to maintain the mapping of all the values. I can't just talk about primitives anymore. I can't talk about this was a string, now it's a this. Like this is, I have no patience for this. So let's look at some more reasonable code, right? So this is some, I would propose this as a better alternative for what we just saw. We've got a normal null flow. We've got variables again, right? We've missed variables. And at the end, we have a nice exception, just being able to be thrown into the wild. And when we run it, what do we get? Sure enough, exception at runtime. Glorious exception at runtime. I'm so excited to see this again. I'm seriously, this is great. So now that we're all on the same page, let's go. So I propose this is cleaner. This is a clearer method. There's no options anywhere. Option is prolific, right? Once it gets to your code base, it's like a little rat and it gets everywhere. It touches all your types. Garbage. Bunch of nonsense. And look at this. We get Java interrupt for free. No extra boilerplate. Yes. So exciting. So that's great. Refined types. This is going to be somewhat controversial. We've seen there's a refined library available for Scala. Shapeless has refined types. Scala Z has refined types. Let's look at how like a normal implementation of type refinement works in Scala. So first of all, we got this thing tagger. This is, for those not quite indoctrinated into Scala quite yet, the way that this works is we have a type T. This is a generic thing. A trait rather is more, it's like an abstract class, right? So we can think of that way. Apply. That's just going to wrap our value as a new type. It's going to actually have the base value with another type. We can actually see this work, right? So if we have, we've defined this thing asset ID, which is a tagger of long. So if we give it a long, it will give us back a tagged value. This value cannot be used anywhere that isn't an asset ID. So I know, follow me, just hang on. So we've got this normal long, 1, 2, 3, 4, 5, which is a good long. I like that long. If we run this thing, we actually get, what is this? Why is this? This is a long, but it's not a long. Why? So we can unpack it, and we get, we unpack it, and where'd it go? Oh, there it is. We unpack this thing, we get the same long back. So we can round trip through this thing, which is incompatible with other longs. That's not really playing nice, is it? That's kind of antisocial behavior for longs, I would think. So let's look at a more real, kind of real world example of this. So I'm going to say, define some normal types. These are some normal data structures, or not data structures. These are normal values that you'll see in your thing. Your thing being your program. I don't know. So we've got strings. We got 3 strings tagged with these arbitrary semantic bits. So what does this actually buy us in the normal everyday world? So we've got Thomas Anderson encoded into these things, tag types, refined types, whatever. We've got a function. This function extracts values and then uses them to provide a new thing called formatted name. So this is cool, but what does it actually do? If I give it a formatted name of the first name and the last name, I get back a formatted name of the formatted name. But I know what you're thinking. This seems like a lot of work. I had to define the types. I have to use the types. I have to unpack, pack, repack. This is already way too much. So also, what if I want to flip things? What if instead of formatting a name this way, what if I'm moving to a different country where they have the names backwards? What if I'm implementing a completely different application that has different requirements on the front end? Now, I can. That's odd. Oh, it should have worked, or it shouldn't have worked if yeah. Wow, live coding in a demo, that's nice. Sorry about that. Well, that shouldn't have worked. I don't know why it didn't work, but that does actually reduce the viability of what I just showed, right? So let's pretend that didn't do that, because it's been working all of the other places. Actually, I've got an idea. Let's try one more thing. Check it out, right? All right, here we go. Bear with me. Yeah, so run. Yeah, okay, so we get an exception because we can't actually use these values in that way. We've swapped first name and last name. They are incompatible types. But as we just saw just now when it broke, it worked fine. Why do we need this? So if we look at an alternate approach to this is maybe a more reasonable way of doing things. So we've got this brilliant function here, string to string, returning a string. This is glorious. This is actually tangible. We can talk about this. And also, if we flip first name and last name around, look at this. Bam. It's backwards and it works. It compiles. So this is really cool. Now, the justification here should be obvious, but just in case it isn't, let's look at some reasons. We've got primitive types already, right? We've got string, we've got long, we've got int. Use them. Just come on. Everybody already understands these types. These are practically the tools of our forebearers. In the programming ecosystem, all these types are available for us. It's a forest of types that are all primitives. It's great. I love this. So here we go. Last one. Check this out. Right? Looks the same, does the same thing, just use the same function. Problem solved. No problems whatsoever. Now I'm formatting completely different things with the same function. It is the ultimate copy-paste, kind of just, Stack Overflow programming in your own code base. It's great. So nice. So here we go. Last one, type classes. This one's a big one. So hold on to the end because I'm gonna actually unwrap this thing for you. We can actually make meaningful use out of this. So here we go. I have 2 things. One is an announcement, one is an account. Both of them have images. They have different structures. So what do I actually want out of this thing? Let's say I'm writing a blog system. The blog system needs to be able to display both announcements and accounts on the normal kind of homepage, whatever. So I need to format data for the end user. This is a normal everyday task. We like these types of tasks. These are easy to implement. Simply get the value out of the thing. But what happens when you want to add a level of abstraction? What happens when you want to genericize the values that you're talking about? So what we can do is we can provide this thing called presentable. I pulled this name out of my butt. This is just how this works. We are going to instantiate not only the trait, which defines two abstract methods, title and display image, and we are providing a presentable object that has two helper methods. These take implicit parameters. I apologize to non-Scala developers. This is how we have to do things. So implicit parameters for the uninitiated are able to pull implicit values based on their types out of the implicit scope, which is kind of like, imagine like a plastic bag that you would get from the grocery store, but it's huge and really ill-defined. So that's where we're going to pull in, like these implicit values from. So this is great, right? So that's cool. Let's look at implementations of presentable. So we can see the presentable announcement is implicit. It's an object, which means it's tangible, we can touch it. We have a presentable announcement, that's the type. That's how Scala will resolve these definitions when we're looking things up in the implicit resolution scope. So then we provide two definitions, title and display image, for both types that we want to display. This is cool. Cool, right? So let's define an account, and let's try and just pull without actually specifying. Notice that we're not specifying presentable account or a presentable announcement. We're just saying presentable. Figure it out for me, compiler. I actually don't care what you do so long as it type checks. That's all I really care about. So if we run this, we will see, sure enough, we get two strings back. One string, one image. So the string test user from the user, we get the user's profile image from presentation image. So these are the values that we expect to get back from running this implicit resolution function. So we're using the compiler to help kind of knit our code together for us. This is really all that's behind a type class, right? One added benefit that you'll hear other people say is you can extend a type class by providing another implicit value that defines the presentable instance for a completely different type. So no need to go back and rewrite, recompile, rebuild your library. You can just say, expose an interface and other people can implement it. So this is kind of cool. But what does this actually get us? I say this is better. This is a straightforward, simple, any matching. So any, actually legitimately any value is okay to be passed in here. This is cool. We only match on two types of values. But any value is accepted. So this is good. So we take all are welcome to this function. So just kind of come on in, everybody. So this is what we can expect. Sure enough, if we pass in user, we get the same values back. So it didn't even lose any specificity. This is like really great. This is a huge win for pragmatism. Now, I know what you're thinking. So we've defined this other thing, post. So we pass in a post. Oh, it compiled. Look at that. We didn't get a compiler error. This is great. When we try to use it, maybe it will explode. But the reason is because we didn't specify it in the case class matching. So if we didn't pattern match on that type and pull out that value and deal with it appropriately, what can we expect? We're just programmers. But here's the really exciting bit. This is an exercise in defensive programming. This is how we can kind of regain the fun of being developers again. We can go in and add these try-catch blocks around everything. Just like Java. Yes! This is so good. I'm really excited. So, I know. Just gotta, this is it, right? So let's look at my core code. It clearly doesn't change. I didn't change it literally in the same slide. I didn't provide another instance of a presentable thing in the same presentation. Your core logic is never going to change. Your business logic, your requirements are going to stay the same forever. So all the behavior is defined in one place. This is amazing. This is so good. Because you have this kind of central repository of truth where you are the king or queen of this repository. Everyone who wants to enter has to come into your domain. You grant access. This is good. Right, so trust me on this one. This is good. So let's look at now. Do I have time for another section? Yes, no, Whoopi? Yeah. All right, here we go, advanced track. So this is originally supposed to be like an hour talk, so I've just been zooming through. So validation. First of all, show of hands, who's done Scala at all? Okay, cool. Who's done Scala Z? Nice. All right, now, who's done Haskell? Woo! All right, so this isn't going to fall entirely on deaf ears. This is going to be good. So, validation. Validation is an amazing thing from Scala Z. I'm giving them this because they've done something kind of cool. This is I'm going to say some words just as a prefix here. I'm going to say the words validation, which I've already said. I'm also going to say applicative. So applicative. Some of you may know what applicative is. An applicative is just a way of representing doing stuff. Let's leave it at that. So the definition of applicative is it's coming in. So let's look at this. So this is a simple definition of validation. Validation has two cases: success and failure. Both of them are parameterized by the types that they represent. And validation itself is parameterized by two types, either the error case on the left or the success case on the right. This is generally applicable and applicative. You can use this stuff. So these are also defined elsewhere. I just defined them here to make them look less scary because they're one line, right? So anyway, the next thing is we can go to this type alias. Now this is where things start to fall apart. This is where people start shutting off their brains because this isn't Scala anymore, is it? This isn't, well, definitely not Java, that's for sure. So what we've got here is a type alias, valid or error strings, which accepts a type parameter. This thing allows us to reduce a lot of boilerplate. And that is really, at the end of the day, one of the core takeaways of this. So I like this. I don't like everything, but I do like this. So these two methods, success and fail, basically wrap around a value and allow us to construct things easier because that's another thing in Scala. There's a little bit of boilerplate occasionally. You might hear people talk about boilerplate. Happens. Oh well. So applicative. Now this is the meat, right? So this is where we define basically two functions. We've got wrap, which other people call pure. I'm calling it wrap here for space. We've got call, which people sometimes call app, and I've called it call for clarity, because those are pretty much the two functions that you're going to be dealing with the most when you're talking about code like this. This wrap takes a value and wraps it in a context. CTX stands for context. So this is actually like the most code that's been on the slide so far in a single definition. So please bear with me. I'll rip this stuff apart soon enough, don't worry. So we are also going to need one more thing. So see this harmless little lift down here? This takes a function from A to some result, and then takes an applicative value and gives us the applicative result of applying that function. So that's great, but how do we actually use this in the real world? This is a lift, in a sense, allows us to talk about code in a different scope. But what if we want to pass more than one function? This is Scala, not Haskell. So here's where I may have written something similar to a compiler macro. So this is where I'm going to ask you to take a leap of faith with me. So come along with me to the definition of this complete garbage and noise, because I wrote it and it is my baby. So, that's what happens. So, now that we've got this thing, let's define a validation context, which is also, I will say, a type class, because you notice that this is an implicit thing that corresponds to some type, parameterized by some other type, which happens to be the type alias that we defined earlier, which gives us a little bit less boilerplate, which is great. So what are we doing here? We are taking, in wrap, we just wrap things in success. We assume that anything that you give me, as I'm a provider of applicative, if you give me a thing, I'm going to return the value that makes the most sense in that context. So in this sense, we don't want to start with a failure, so I'm going to start with a success. So we start with the success, and let's just kind of leave it at that. So we've got call. Call is the interesting thing. So if you think of call, remember call is sometimes referred to as apply. So if you go and look at the documentation later, this graph. So we've got two functions. We've got two values. We've got FA and FF. So FA is the value that we actually care about. FF is the function that we care about. As we described earlier, we can have functions in this scope. So if we unpack both A and F, we get values. Both of them are success. We can apply A to F, wrap the thing as a success, and call it an A. This is good. If we get failures in any other case, we return failure. Silence. It's good. It means thinking, I think. So the important thing to note here is that valid or error strings is plural. And because it's plural, we can accumulate multiple errors. This is the thing that these functional people will have you believe is only possible in functional code. So, see where we have these two Fs? Well, we have F and A. Both of these are failures. So we're actually concatenating failures. So we can accumulate multiple failures. Who cares? So this is great, but really, who cares? So let's go add to. This is a typical instance of, seriously, noise. So if I call with a value, the value being one of these things, and I call a wrapped function with this value, like seriously, I wrote the code and I can't even explain it to you. Let's look at what it does. So we've got add to success. What do we get? We get success 4. Yes, it worked. I'm excited. So let's go. What happens if we add a failure to this thing? We get a list of a single string with failure in it, which is really good, because that's what I hoped was going to happen. So I promised you that I would unravel this nonsense. I promised you that I would provide real, tangible, real-world alternatives to this. And we're about to see one. It is called, what the heck? It is called more of this, which I forgot that I put in there. I wasn't actually planning on going over this. So let's look at this. So we've got a couple more of these. I'm going to run through them really quick. So validate username, exactly the same thing as we just saw with add, except now we have a function that takes a raw username and returns one of these applicative context validation things. We can fail if we have an empty string. We can fail if the user has entered foobar or baz as their names, because that is not a valid username. I know, I wrote the code. If their name is longer than 16 characters, that is also not a valid username. I take exception with systems that have 15 character length maximums because my nick is 16 characters. So every bit of code that I write, 16 characters or more, please, if you write a system, allow usernames of 16 or more characters. I really appreciate it, thank you. So let's go on. So we've got email validation. This is so cool because it's from the UK, it's from the British government. We got real international code in this thing. It's cool. So let's go on. Raw age validation. So if you are less than 0 years old, I call it shenanigans. So let's put all this crap together. So we've got all of these raw types going to their non-raw alternatives. We've got their lifted alternatives for each one of these types. Validate string is going to wrap any string with this applicative stuff. So we can actually use this as sort of like a meta thing, meta builder, that will build these validators for first and last names. Cool. So how do we use this? We can lift an instance of user's apply method, which takes 6 arguments of primitive types. Using lift6, which I provided earlier, we saw the code, it was horrible. We can use this macro to lift all of these values that may or may not actually be valid values into this validation context. Does it work? Let's see. I'm going to create a user. Look at that. Instead of getting a plain user, we got a user already applied, already built up in this applicative context. This is super cool because we actually have this composable thing, I guess. We can actually talk about this thing, and if we have failure cases, we don't get exceptions anymore, which, some people, sad. That's how that goes. Can't please everybody. Let's look at some real alternatives. Let's look at I would say, at least easier to reason about alternative. So let's look at, oh yes, more code going off the screen. So, this is a simple name validator. This is going to do the validation that we had before, but now it's going to return either of left and right. But see, left and right are both strings. Instant win, readability, as I said before. Good. Second thing is, validate email. Same email validation code, also string to string or string. Great. Now, if we validate the age, we've got stringer int. Okay, slight loss there. Yeah, sorry. Validate name, back to string, string, string. Yeah. Now, create user. This one's going to be a little bit different because it's going to return either of a list of string or the user. Okay, fine. This one's going to be a little bit longer because we have to do a lot more boilerplate because we can't use applicative. Sorry, it's just going to go, trust me, it goes up. So if we run this thing, we're actually going to see, sure enough, we have a successful result. We've got right of user, all this stuff. Either built into Scala, by the way, and also, bam, look at this, we got error accumulation as well for free plus boilerplate. Yeah, it's great. I'm excited. So this is pretty much the end. Let's go over what we learned. Option. I like, as I've mentioned now before, I like null pointer exceptions. They keep the brain sharp. Option also, I mean, this is our legacy, right? We've come from a long line of developers that use option in their day-to-day lives. Some people more than others. Type refinement. We can describe the meaning of a type without having to use more documentation that's in the type system. The type system helps us. We can kind of reason more strongly about the code that we're writing. We can actually have these refined types just show up in the middle of functions. We hardly even need documentation anymore, right? But now I can't just pass whatever to whatever. So it's really kind of restricting me. I'm feeling oppressed. That's not cool. Type classes. We've got a lot of extensibility. This is great. We can extend things without going back to the original code. We can just use the explicit API defined in the trait. We can provide instances of that API. We can use those instances of the API everywhere that we already define these things. Super great. But what we lose is living documentation. The code is no longer clear where these things are coming from. So, your choice. Validation, compositional error handling. So this one, I came up with these words. Maybe they're not accurate, but I think they are, but maybe not. So what we've got is we've got error accumulation from multiple sources. Some would say effortlessly. I would say somewhat effortlessly once you get past the boilerplate. But fortunately, people have defined the boilerplate for you, so you really don't need to do this stuff. I mean, I did it in the slide. So, I mean, you can take this stuff either by adding dependencies into your code base or just kind of rolling your own thing and then realizing it's hard and then going and adding those dependencies. So you have choices. You have two choices. Or you can like go back and really, if you're a contractor at least, this is the real takeaway, right? We want more billable hours. We want to be able to say to our contractees, hey, I actually worked an 80-hour work week looking for one null pointer exception that was like tracing all the way back to the database. Who knew that was so difficult, right? It's 2016. Let's keep it going. So, anyway, that's all I got. Thank you very much. I think I have a couple of seconds for questions. No?
You still have like 20 minutes for questions.
What?
They lied to you.
They lied in the biggest way possible.
There's one way bigger, which is functional programming is great.
Oh, that's true.
They could have lied the other way.
Could have been a 15-minute talk. Could have been a lightning talk.
Yeah.
So I apparently do have some more time. I would love to answer questions because I kind of breezed through this stuff. I am kind of like pull the mask aside a little bit. I am a functional developer by day, but I'm going to put it back now because it's more fun this way. Who wants to ask a question to either persona? Go for it.
You argue for type classes and traits and things like that, and these are typical OO programming actually. It's not what is typically called functional programming.
Okay. But
like
this is
it's adult polymorphism.
Yeah. No, it totally is. I think the main takeaway for me is that I've been in companies that wrote the second way, like a lot. They didn't even embrace these basic concepts. And I had never heard of type classes until I even got to Haskell. So even though this is probably true, I mean, obviously I'm not using any advanced techniques other than implicits, but I could pass the values explicitly. But the main thing is that you don't really encounter this stuff until you get to the FP world. So I thought that these were relevant topics. Any others? Come on. I'm just going to start playing video games. Let's do it. Anybody? Going once? Twice? All right. Thanks, guys. Oh, wait. Ah! What have you done? Now they're going to have to clap again.
So as a new developer at FP, how would you suggest getting into this?
Whoa, that's a great question. The question was, as a new developer to functional programming, how do you get into this? So I'm not going to lie, it is pretty difficult. Depending on what language you're coming into, there are definitely different tracks. I gave this talk in Scala. There is an abundance of resources being written by the day in both the CATS community and the Scala Z community, trying to make this stuff more accessible to more developers. They really kind of, we're in flux right now, so that's all I can talk about right now, because we actually have both Scala Z and CATS code in our code base. So I mean, they play well together, but they are completely different like groups of people kind of both working towards the same goal. So I'm not going to be able to say anything more than that because I'm not a developer or contributor to either of those projects. Beyond that, Shapeless. You've probably heard of Shapeless because there have been a couple of workshops about that. Shapeless is an amazing tool, and it is also extraordinarily difficult to get into it if you expect it to be easy. But if you expect it to be just a little bit harder than you're used to and just kind of work through it, there are still some things that you can do just right out of the gate. So for instance, we started with lenses. Lenses were amazing. Validation from Scala Z was another way that we kind of like snuck this into the code base. We replaced this huge, it was like probably 200 column width, like just massive. For doing 4 validations on a form, 200 columns of like nested try-catch expression, like case expressions, all this crap. So like we reduced this into a linear flow that accumulated errors using validation. And my coworker implemented it. Like I didn't even know what it was when I first came to it, but after reading a little bit about it, they actually have these primitives defined that work really nicely together. And I heard that they're even better in cats, but I also shouldn't say that because I haven't verified it myself. So I would start there. There's a little bit, just as a note for those Googling around, there is a now somewhat antiquated set of blog posts called Learning Scala Z. These are an amazing resource for getting started, but what I will point out is what they are is some other person writing a blog post about their experiences learning Scala Z. So it also an older version of Scala Z, I should also say. So not all examples will compile. Not all examples will be perfectly binary compatible with like what the current or API compatible with the current version of Scala Z. What I will say is that looking there for starters and then kind of taking it and running with it, great. Obviously Haskell, I mean there's now Learn You a Haskell and also Haskell Book. Haskell Book, we've got the coupon code on your in your little bag thing. I've heard that is an amazing way to start. A friend of mine's going through it right now, and he said it's like seriously the best Haskell book that he's read. I know someone who's read it 3 times at various levels of depth, which I find really a really valuable strategy because each time you go in, you learn more stuff because the later stuff informs the previous stuff. This is really learning 101. So I'm not saying anything new here, but I am saying that is an amazing resource. The other thing is that a lot of the stuff that you learn in the Haskell community and world applies to Scala as well, and I think that it also applies to, actually I'm not going to say that because there are other, I know that it applies in some sense to PureScript, it applies in some sense to Idris, which are also like, there's just, this is really the time, right? This is such an amazing opportunity with a wealth of information on how to actually get started and get up to speed in all of these different components. And also, you don't have to take them all at once. This is really this is the ultimate in piecemeal, because every time that you write something, it is by construction going to tell you if you've made a mistake. It is by construction going to tell you if you've changed something or if something has changed around you, where now you have to go back and fix this thing instead of finding it in production runtime like 3 months from now when you've already forgotten the code. The types are descriptive, right? So even when I talk about option wrapping null, this is such a trivial thing. This is replacing a null value with a type that represents the branch of null. And we can talk about this in a real way. We can say we can map over this value, we can flat map over this value, we can bind and Haskell over this value. Amazing. We can talk about these things in the abstract instead of actually encoding our business logic as a series of try-catch or as a series of if expressions testing for null. If you apply this in a more general sense, sure enough, you've got amazing amazing tools at your disposal for even using abstractions that other people have written that provide the thing that like 500,000 people before you've already thought was an issue, right? So, yeah, that's pretty much it. So, any other questions? Yeah.
So you mentioned about it being piecemeal.
Mm-hmm.
What are the like best constructs to get started with and use and
Yeah. So I've heard conflicting. I have heard conflicting advice here. The good news is the conflicting advice is not mutually exclusive. It's just where's the best place to start. As I mentioned, I got started with just simply option and moved on from there. Actually thinking about semantic modeling of my underlying data. We don't have dependent types in Scala yet. I think they're coming in Dotty, so that's going to be cool. Dotty is the next Scala compiler, so if you're not a Scala developer, then ignore this. But if you are, then Dotty. Once you get on the road of thinking about transforming containers to different representations of state, different representations of the valid values that could be in any given computation, even if it's something like this string should not be empty here. Even if it's a completely valid thing to have a string that's empty, but it shouldn't be empty here, or it should be empty here, but I want to know about it. These things are all encompassed in these low primitives like maybe in Haskell, option in Scala. If you define a data, like if you in Haskell you can say like data like valid string is empty or has something string, right? So you can actually define this representation. Wow, that's down there. That's weird. So you can define this representation of a valid string, and that means something to you, but not anybody else. But this is actually really powerful, because now you can take that thing and build more, not abstractions, because abstractions is also like that's a huge rabbit hole. You don't have to go that deep yet. You can if you want to, but that's also not for everybody, especially when everybody else, like all the functional like communities are writing all these really cool things for us. So pulling out things like applicative, I chose applicative here because it is a really core fundamental component that fits on the slide. It's there. So the definition was a little bit opaque, but I mean, if you walk through it, this is how you learn stuff. So starting with I've heard, starting with Kleisleys, starting with natural transformations, talking about the transformations of two classes of these types of data constructors, data things, talking about the transformation of those things, just kind of playing around, not even necessarily bringing it to production, because that's also, it's hard, right? And I'm standing up here saying, hey, just invent some free time and just do a lot of extra work for nothing. But what you get out of it, right? This is one of the reasons that I went from Python to Haskell to Scala. And the reason that I went back from back from Haskell to Scala is because I could get like a job. This is going to be also somewhat controversial. I could get a job at my level, right? So I wasn't at the time, and I'm definitely not now, super FP dude. Like, I'm not that guy. At the time, even worse. I had just come out of Python land. I had no idea what I was doing. But you can start easily. It's not, you don't get born with this stuff. So just starting with options, starting with maybe, going to maybe functor, looking at why a list is a functor, or if that is even interesting. A lot of people say start with monads. Monads are like, whatever, just like, there are other things that are more interesting than monads. Monad is not the end-all be-all of functional programming concepts.
Not strictly relevant, but what presentation framework is this?
This is called a heavily patched version of Represent. Represent is a build tool, or not a build tool, it is a presentation tool written in the SBT. This seems like a great idea, and it needs a lot of help. So I wrote a significant amount of tooling around this tool to make it less very painful to work with. But it's all in the repo, so go check it out. I'm going to open pull requests. There's a Vim syntax file for it now, but it's not anywhere. So stuff will come out gradually. But Represent is an amazing tool that seriously abuses the SVT, like the Scala console. You have to turn on power mode in order to do this, which is great. So anyway, I saw another question. Yeah.
What's the repo? What's the repo?
I'm sorry?
You said, where is the repo? What is the GitHub or whatever of the repo? You said
Oh, yeah, sorry. So the repo is... that. I think, should be. Yeah, if you go to my GitHub page and then swap down to the FP is Overrated branch, this is the whole outline of the talk, and then additionally, this kind of describes how I got Represent to do what I got it to do. There's seriously, there's gonna be stuff that I'm gonna submit upstream because like it only reads from one giant text file, for instance. Like that sucks. So I made it like I wrote a make file that just cats a bunch of files together. I added some structure to it that enables like branching. It's horrible. Don't read the make file. Yes.
Was it ultimately beneficial to go from Haskell to the Scala? The Scala is a pure function, gives you a lot more ways to shoot yourself. So now you know more what to look for. Like, was that a good strategy? Because I do Scala, but
Yeah.
I'll have a hard time getting deeper into like strict function.
Yeah, no, so the question was it beneficial going from Haskell back to Scala, even though Scala is not as strict as Haskell? As a learning experience, I will just, like, I'll take the heat if this is wrong, but I say learn as many languages as you can, because each one of them provides a different perspective. My first language was Perl. Right, yeah, woo! So, it's like Perl to C to Perl again. So, but just having that experience has really informed me as a developer. Going from a significant number of years kind of in Python land to Haskell was like, I tried to learn Haskell for like 2 years. Reading the book again and again and again, like my copy's all messed up now. So it was like, it's hard. I'm not saying it's easy, but it was also my personal discipline. I at the time didn't need it enough. It was still kind of like they say this about learning like natural spoken languages. They say that you shouldn't learn a language just to impress people. You shouldn't learn a language because maybe it'll be cool or maybe it'll look good in your resume. You should learn a language, and this applies to programming languages as well. You should learn a language because it solves a need. This Haskell didn't solve a need for me until I realized that I had been writing the same exact Python code for 5 years. The structures were the same, the abstractions were the same, the exceptions were the same, 5 years. That's when I said, maybe I need to make a slight shift in my mindset and try something else. And I've heard that Haskell is super difficult and it's going to make your brain explode. So that's kind of the direction that I went. Sure enough, we're all here at LambdaConf. So maybe some other people like Haskell too. So yes, it was beneficial to go to Scala from Haskell because it gave me a different perspective and it taught me the things that I was missing in Python that were provided by Haskell that I once again lost in Scala, right? So, any other questions? It looks like more people are piling in. Anybody? Yeah. Going once? Twice? Thanks.